The last part of section 1.5, our goal is to take the four methods that we've looked at for solving quadratics, which are what? Four methods. Square rooting is one. Quadratic formula is one. Somebody else. Completing the square is one, and factoring, okay? We want to take those four methods, and we want to figure out which one is the best method in each situation. Okay? So, on the first page of your notes, you have 5 questions. I want you not to solve them right now. I just want you to go through the 5 and try to determine which method would be the fastest, most efficient way to solve it. And you can't say quadratic formula for all of them. Okay? I want to see all 4 methods used somewhere in those 5 questions. So the directions here say to solve by the best method possible. If you look at the 4 methods, factoring sometimes works, right? But not all quadratics are factorable. Square rooting sometimes works, but not if there's a middle term in there. Completing the square and quadratic formula always work. You can solve any quadratic by completing the square or using the quadratic formula. The problem is it's not necessarily the fastest route. Okay? So, looking at the first one, what method did you pick? Factoring is your best option on this one. Remember I said every method had to get used once. Okay? This is the only one on this page that is factorable, so we have to use factoring here. All right. If I'm going to factor, I have to have one side equal to 0. So I'm going to move that 31x to the other side. It is the middle term, so I'm going to put that in between the 6x squared and the 5. And how can we factor to get that 31 in the middle? Okay, 6x and 1x. To get the 5 on the end, we need a 1 and a 5. All right, if I put the 5 here, I've created a 30 on the outsides. Can you guys see that? 1 in the middle. What signs do I need? Both negatives, yep. All right, so my solutions here would be 1/6 or 5. All right. So done very quickly by factoring, right? Much faster than going through the whole quadratic formula. Now it also asks you to match it up with the picture. We did a little bit of this yesterday. If I know that my roots here, my solutions, are 1/6 and 5, where am I going to see them on a graph? What are those? Where they hit the x-axis, we call those what? X-intercepts, yep. So we need a picture over here that has x-intercepts at 1/6 and positive 5. What picture looks right? Second one here? All right, so put a number 1 by that. That one goes with question 1. All right, question 2. What method did you pick? Square rooting is a good method on this one. All right, but before we square root, what do we have to move? Yes, divide out the 3, which gets us what? 45? And now when I square root both sides, I end up with x being plus or minus square root of 45. What could we break that into? 9 and 5, so 3 root 5. All right, so plus minus 3 root 5 would be my 2 solutions, my 2 x-intercepts. Now obviously 3 root 5 isn't going to jump out at me on my graph, right? But what is an approximation for that? If we look at the square root of 45, it's close to the square root of 49, right? Which means it's close to 7, a little smaller than a 7. So we need a picture that has x-intercepts at about positive and negative, we'll say 6.8, something close to a 7. Which picture shows that? The third one? All right, so this goes with question 2. All right, question 3. What's a good method for solving that? Yeah, that's another square rooting one. You already have the one side squared, so it's easy to square root both sides. Okay. On the left-hand side, we end up with 3x minus 1. What do we get on the right? What do we get when we square root negative 1? We get an I, right? So plus minus I. And then how would we finish solving that for x? Add the 1 over. Okay. So it becomes a positive 1 on the other side. And then my last piece would be, yes, divide out the 3. So I have 1 plus minus I all divided by a 3. Now, if it's an I, right, imaginary, are we going to see it on our graph? No. So this means we are looking for a picture that has no x-intercepts. It's still a parabola, right? But it doesn't have any x-intercepts. So which picture? The bottom one? All right, so this one goes with question 3. How many of you chose for number 4 to factor? Did anybody pick factoring? A lot of students do because it appears to be factored. But when we solve by factoring, we have to have one side equal to 0, and we don't have that. So in order to get one side equal to 0, we're going to have to get that 2 brought to the other side, which means we're going to actually have to FOIL this out. Even though it's already been factored on the left, we're going to have to FOIL this back together, move that 2 over, and then analyze what we have. Okay? So step 1, let's refoil the left side. 4x times x gets me 4x squared. What do I get for insides and outsides? Okay, 7x. Last term is a 3. And if I bring that 2 to the left side, I have 4x squared plus 7x plus 1. Is that factorable? You can try it. We've got 4x and x, right? Or 2x and 2x. Only way to get a 1 is 1 times 1. Do any of those get me a 7 in the middle? Okay, so factoring isn't going to work here. What is my best option? Which 2 methods did I say always work? Quadratic and completing the square. But to complete the square, my first step would be to divide everything by 4, and it's going to create some fractions, right? So in this case, quadratic formula would be your faster route. So let's go ahead and solve this using the quadratic formula. X equals the opposite of b plus and minus square root b squared minus 4 times a times c, all divided by 2 times a. All right, simplifying. Inside our square root, I've got 49 minus 16. 49 minus 16 is 33. Is that a perfect square? Are there any perfect squares in it? Okay. Square root of 33 is close to the square root of 36. So it's around a 6, right? It's a little smaller than 6. So if we're estimating answers here, we have negative 7. We'll just say it's a 6. It's going to be a little smaller than that, but we'll just estimate. Negative 7 plus 6 would be negative 1 over 8. And then negative 7 minus 6 would be about negative 13 over 8. So we need a picture that has something around negative 13/8 and negative 1/8. Again, it's not going to be exact, but an estimate. Which picture looks correct? That first one? All right, so this was number 4. All right, so we have used factoring, we've used square rooting, we've used quadratic formula. What's my other option? All right. Is this last question set up to complete the square? It is. They've already moved C out of the way. And your middle term is a nice even number, so we can cut it in half evenly. All right, I'm just going to leave a little hole there. How do I find that middle number or that missing number at the end? Middle one divided by 2 and then squared. So if I take 8, divide it by 2 and square it, I get what? Okay, so I have to add a 16 to both sides. On the right-hand side, I have 17. On the left, it factors into what? Yep. All right, so we have x plus 4 quantity squared equaling 17. Next step, square root both sides. So x plus 4 equals plus minus root 17. Last step would be to subtract the 4 over. Estimating those roots. Square root of 17 is about 4, right? A little bit more than 4. So we have negative 4 plus, we'll say 4.1. So we have 0.1, a real small positive root. And negative 4 minus 4.1, we're at about negative 8.1. So look at our remaining number, our remaining graph here. We have a slightly positive root. We have one about negative 8. Okay. So as you go through your homework today, we do have a few more questions to do, but as you go through your homework today, make sure that you're looking at it and really picking your best option. I do not want you to solve them all by quadratic formula. Okay? If it's factorable, use that. If it's set up already for a square root technique, use that. If you can divide nicely or you already have an A of 1, completing the square is pretty easy. All right? But don't rely on that quadratic formula for everything. All right, we have 3 questions left. I'm going to pause the video. I want you to work through this one using the quadratic formula and discuss at your tables what kind of solutions you're getting. All right, going through quadratic formula, we have the opposite of b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And simplifying, what did we get underneath that square root? We have 25 minus, what was it, 84? 25 minus 84 ends up being negative 59. And what happens when we have a negative under our square root? All right, so we end up with an I root 59. Yes? Would we see that on a graphing calculator? Would we see those x-intercepts? No. Imaginary ones are not going to show up. I do know that it opens up. How do I know that? Look at your original equation. How do I know that it's going to be a parabola that opens up? If that's positive, it opens up. If it's negative, it opens down. So I know that this one is going to open up, and it doesn't cross the x-axis, so it has to be somewhere up in quadrants 1 or 2. Okay? All right, the last 2, we're going to look at word problems here. It says use the Pythagorean theorem and the square root property to solve the following question. Express your answer in simplified radical form. That means things like 3 root 2. Okay, simplified radical form. And then also round it to the nearest 10th as a decimal number. All right? What is the Pythagorean theorem? All right. We use that to solve side lengths of a right triangle. All right. Our question says a rectangular park. We have a rectangular park. It says it is 16 miles long and 8 miles wide. How long is a pedestrian route that runs diagonally across the park? So they're looking for that length. When we go to use the Pythagorean theorem, which side is that diagonal? How do we label that?
C.
That's your C. Yep. All right. So Pythagorean theorem says a squared plus b squared equals c squared. So 8 squared plus 16 squared equals c squared. What's 8 squared plus 16 squared? All right. So we have 320 equals c squared, which means c is going to have to be the square root of that. Would it make sense in this context to put the plus minus in front? No, why not? Right, we can't have a negative distance, right? So we're going to look at the positive square root of 320. Let's break it down. We want a simplified radical answer. What's a perfect square in 320? What? There's a bigger one than 4. $64 goes in there how many times? All right, so this would simplify to be 8 square root of 5. All right, but most of the time, people aren't going to say, hey, I'm going to go on this walk. It's 8 root 5 miles long. Okay, so what would that be as a decimal? What's the square root of 320 as a decimal number? 17.9? Okay. Last question. It says, the area of a rectangular wall of a barn is 28 square feet. So they're giving me the area of the wall. It says its length is 12 feet longer than the width. So let's picture this. We have a rectangular wall. If I call this the width, it's telling me that the length is 12 feet more than that. So W plus 12. And then it's telling me the area is 28 square feet. How do I find the area of a rectangle? Length times width. So I need to take W times W plus 12. W times W plus 12. Length times width has to get me an answer of 28. If I distribute on the left side, we have W squared plus 12W. Which of our methods would we use to solve this? We could complete the square, right? We could take half of 12, square it, add it to both sides. This one actually is factorable, though. Let's bring the 28 over. And then how would we factor that? We need it to multiply to be negative 28 and add up to 12. To get a negative 28, we're going to need one negative, one positive, right? Okay. Does that work? Yes? So my possible widths would be W equaling 2 or W equaling negative 14. But again, in this context, we know W stands for the width of the wall. Can the width of the wall be negative 14 feet? So in this context, I would say this is an extraneous solution. It does not make sense. Okay? If I hadn't given you the word problem, if I had just given you the original equation to solve, you would have given me both answers. But in this context, we would eliminate that negative 1. So that tells me the width of the wall is 2 feet. And what would the length be? Length would be 14 feet, W plus 12. Okay? So again, as you're going through your assignment, make sure you are choosing the best method